Hi, so I am Carolyn Phillips. I work at Wayfair. I'm a senior staff machine learning scientist. What I'm talking about today is a topic that is very personal to me. This is a kind of a reflection on my experiences of what I've worked on over my career. So, oops, you know what? I don't have the clicker. Oh, thank you. Click, click. Is it?
Oh, it isn't here.
Aha, all right, no problem. All right, so, and that is this. I think the open secret of enterprise machine learning across the industry is that ML models are often not built and deployed according to what we know are the best practices or with state-of-the-art platform tools. You come to a conference like this and everything looks cool and amazing, and there's usually like a little nod to there was a real struggle at this part or that part. And I think one could almost forget how hard it is to actually get a model into production, adding value. I think somebody had a statistic here that was like some large fractions of models that are built never get into production and actually add business value in the end. It's hard. So I feel like this is like the reality that we often are struggling with. And I want to think about why. Why does this happen? So how do we keep ending up here? How do we keep ending up with these struggling products these machine learning products that we're struggling to get into production? My answer number one is there's absolutely nothing that is special about a machine learning model deployment. And my answer number two is there's absolutely something that is kind of special about a machine learning model deployment. So let's start with there's nothing special about machine learning model deployment. You know, there are ways in which, hey, look, a machine learning model deployment is just another example of a complex software system that you're putting into production. And there are books older than me where we've been talking about all the fallacies and like problems and issues and struggles and how do you manage tech debt. And there's absolutely nothing that's different or special about a machine learning deployment when you're thinking about how to get it into production. I love reading these books. I love reading these articles. They resonate with me. There's usually some point in them where I'm like, that's exactly what I'm struggling with right now, but you've said it 10 times better, and I'm gonna use this to like convince people that we're going in the right direction and we have to do this. They also make me feel not alone, because sometimes you feel like I must be the only person in the world, this must be the only team in the world that is like struggling with these issues, and then you're like, no. This problem is as old as time. It goes back to the beginning. And in fact, one of the reasons why these books can be 20, 30 years old and still be relevant is because what they say is a lot of the issues are not the tech, it's the people, it's the assumptions, it's the planning, and that stuff doesn't really change. Okay. So, however, I think there also is something a little special about a machine learning model deployment. And I think this is because there has been this explosion of open source, out-of-the-box machine learning tools. There's been this democratization of the ability to build a machine learning model. I can still kind of remember a little back to the time where building a machine learning model would mean implementing an algorithm yourself. And at that time, where in your company, who could actually be working on this technology? Very small, niche, specially trained teams. And now you can have teams bringing ML solutions into market all over your company. They're just bubbling up everywhere. And that's amazing, and that's been incredibly influential. And it means that like the impact of machine learning is far larger than just like the big foundational models and the chat GPTs. It's like everywhere. It's the little projects. There's that long tail of little projects that are having all this impact and power. However, the democratization of machine learning operations has not really kept up with that. So you've got lots of people building models and more people like encountering the specialized struggles of putting a model into market. Also, what I see is that models are primarily built by data scientists and analysts who have years of experience in statistical thinking, understand that data deeper than like anybody else, understand the business problem, understand the value they're trying to achieve, understand how their model is going to fit into what they're trying to achieve. But they don't have years of experience in maintainable software. And as a result, not too surprisingly, you know, the thing they're producing ends up struggling and having a hard time. Okay. So I'm then imagining I'm going to start like that you come at this from kind of like the outside at first. Maybe you're like a product owner. Maybe you're a tech lead and you have a whole inventory of models underneath you. And you say, okay, I have limited bandwidth, limited resources. How do I know that I need to be really thinking about which of my models and which of my pipelines is struggling? What are the smells? So I'm going to do like a little good smell, bad smell, good smell comparison here. And I like the phrase smell because it also, just because like sometimes a smell, you can smell something, it's a suggestion. It's like you're heading in a bad direction, but any one of these is not like in of itself like an immediate red flag, you're dead, right? But a bad smell is that keeping that machine learning pipeline framework running is actually kind of getting harder over time. It's sucking up more over time. Versus a good smell is it's actually like getting easier over time. There's some basic problems, they get fixed, and then the thing, it generally runs smoothly for long amounts of time. Another bad smell, good smell is getting that next model release out is taking longer. It's like every time you go to get it out, you discover exactly how hard-coded the framework was around that first release, and that second release means you have to like rework a whole ton of stuff. Versus, hey, actually getting new releases out is actually kind of dropping. Now, it doesn't immediately drop off a cliff, but it's dropping. Bad smell, all the changes are coming from one person. That person is the hero who averts catastrophe. Something goes down, you call that person. 12 hours later, they burst into the room and they say, it's fixed, it's good, all right, we keep going. And everybody goes, oh, that's great. And nobody has any clue what they did. Good smell, you might have a central architect. I think you do need a central architect, but you're going to find that there's many contributors who are contributing fixes and updates that are eventually making it into main. Bad smell monitoring is ad hoc, kind of manual, kind of a little on demand. Someone's doing an occasional analysis. And in fact, what you're finding is that your downstream users are the ones who are contacting you over Slack and saying, hey, how come the thing didn't show up today? Good smell rarely is a problem first identified by a downstream consumer team. You actually realize when stuff is breaking yourself, and you actually get it usually fixed and up and running again before any of your downstream consumers have realized that something went awry. Bad smell. Your data scientists are babysitting daily jobs to make sure that they complete successfully. What a waste of a data scientist's time. Versus good smell, you have a system of alerts that you actually feel very comfortable relying on, and they let some accountable person know when something is wrong, and that person goes and they fix it. Okay, so this is a little bit things you can see from the outside. Usually this is kind of when I come into a project and I lift the hood and I look underneath and I say, well, what do I see now? What do I see when I look more closely? Bad smell, long scripts mixing data fetching and data manipulation. Versus good smell, code is broken into modular functional units. Bad smell, weak to no unit testing, weak use of version control, weak use of CI/CD. Versus good smell, all those modular units come with unit tests. All those unit tests are triggered automatically through your GitHub PR process. You have a lot of confidence that this code that is in main is working functionally, actually good code. You don't have a whole lot of fears that stuff is getting into main inadvertently and breaking things. Bad smell, minor variations in logic to handle like a very similar-ish use case are being implemented by copy-pasting large chunks of code and changing a couple lines. Versus good smell, minor variations are handed by, minor variations that you didn't anticipate are going to come along, and when they come along, what you see people have done is they've taken the logic, they've abstracted it a little bit, they've added a new parameter or configuration that gets passed in, and they're basically reusing exactly what they had before with like a couple of changes. Bad smell. There is some data manipulation section inside of your code base that everybody is terrified to touch. They say, look, that is the legacy way that we have always calculated this quantity or parameter across our entire company. We don't really know what's happening in there. It was created by somebody who's not here anymore. Please don't touch it, because that table basically runs the whole rest of our model. Good smell. Every part of your code can be updated and touched. No part is a mystery. The intent is clear and obvious on what everything is doing. Bad smell, you read through the logical flow, and you find relics of past projects. You find dead ends from early development that we're not really using anymore, and they've just kind of stayed in there and hung out. Versus good smell, what you see is there's this steady cadence of continuous improvements and maintenance. And if something is deprecated, it's not too long before it gets pulled back out of the code again because you don't need it anymore. And we don't hang on to things that are just like, little extraneous organs and little extra body parts that, you don't need anymore. They're removed through this kind of natural process of steady cadence of continuous improvements and maintenance. Okay. You've taken your project, you've assessed it, you've looked at it. The smells aren't good. You say, I think we need to invest the time, we need to rework this project, we need to rethink it. Where do we start? This is where I like to say, stop, let's talk about expectations. I think sometimes there's this hope that what's gonna happen is you're gonna bring in some like person, and they're gonna come in and they're gonna do this big job, and then they're gonna go, and you're gonna be like, done, good. I like to say, look, what you're not trying to do is you're not trying to do some big refactor and be done. Your goal is to turn this machine learning pipeline that has kind of gotten very difficult to maintain and understand on the inside and turn it into something that is easy to change. You've heard this statement several times at this conference. The only thing constant is change, so we have to engineer systems that are ready and willing and easy to keep changing. So what your goal is to get to a point where the pipeline is at an easy-to-change state, and that will then be supported by a continuous cadence of upgrades and fixes because, and this is a statement I pulled straight out of one of those fabulous books I read, all software rots over time, and machine learning pipelines are no different. Okay. This is the moment that you've decided to rework it. This is your moment to stop and think about your fundamental service level agreements with this software. As you think about the use case of this, what is the scale of data you need to process? How fast does this process need to be? How frequent does it need to run? If you look at the infrastructure and how you've deployed this model pipeline right now, do you have any hope whatsoever in meeting those SLAs? Or could you make the most beautiful, elegant thing possible and watch it fail to meet its SLAs because it's just on the wrong infrastructure? If you're gonna fix that problem, this is the moment to fix it because you're already gonna be making some big changes. If I push harder, if I point it that way, all right. Okay, next. If you work in code, I find the left slide, which to be very, it's resonant. It's very deeply resonant on what happens when you get inside someone else's code base. If you're gonna go and do a big refactor, step number one is you might be dealing with a code base that doesn't currently have regression testing. And you're going to need regression testing because if you make this code, again, beautifully elegant, but wrong, nobody cares, right? So you want to make sure that you know what working is, and you can, even if the prior creators of this pipeline haven't left behind the artifacts to know what working is and looks like, that you go and create them yourself kind of before you get started, or you have the prior code base kind of parallel there along it, and you can make sure you have some way of cross-comparing what they're doing. The next thing I'm gonna say is you gotta simplify, strip out the relics. If you can't explain what something is doing, dig harder. You got to understand, you got to modularize, you got to decouple, you got to write unit tests, you got to think carefully about how to simplify the logic from one end to another. This is like basically where you just got to do the really hard work. You just got to dig in. And there's not a lot more that you could say about that, but you got to dig in. So a lot of this up until this point hasn't been very specific to machine learning models, but I want to say what I think is a little specific to machine learning models. And that is the complexity of the intent that you can be attempting to extract when you go inside that model. The types of tasks that a data scientist can be wanting to do can be like, I'm doing this data as a data cleanup. I'm doing this to basically replace missing data. They can be really like complicated tasks. If you're lucky, the original data scientist who wrote that code is sitting right there next to you, and you can turn to them and you say, okay, I don't get this. What are you doing here? What are you doing here? And they'll be like, oh, well, we were having this issue, so this is a cleanup protocol I wrote. You're like, okay. If you're not lucky, they're not next to you, and you have to try to, I think of it as like I'm putting on my like archaeology hat, and I'm like, I'm putting myself in the brain of this data scientist, and I'm trying to be like, what were they doing? What were they thinking? What was the problem they were encountering at this point? Why did they write this way? Then there's this issue that sometimes you're going to find that you can kind of sit down, you can extract their intent. This is what they were trying to do. And then you have the implementation. You go, sometimes it's just maybe like an inefficient implementation, but it's fine. Once you've made it a little more efficient, it's going to be the same answer. Sometimes you're going to conclude that their implementation has kind of not handling certain corner cases correctly. It's a little wrong. It's a little wrong. But because it's a model, you have to think really carefully about what the implications are of changing the implementation from wrong to what you believe is more right. Because it could be, you have to think about how the data is flowing through, what has the model been trained on, because you could be in a situation where the model has been trained upon the slightly wrong version of that implementation, and it's kind of adapted to it. And if you actually change that to a correct implementation of that intent, your actual model performance is going to go down. And that's a tricky one. You have to think really carefully. If that happened, do I have the regression testing to tell me that I did that? How do I handle that situation where I can't fix a problem because it will lower model performance? So that's a tricky one. And sometimes those are the things you just have to basically put a little box around and say, next version of the model, we're going to use the updated version. But for purposes of not wanting to disrupt things too much and not wanting to retrain this model, we have to basically live with this for this time. You have to make lots of strategic decisions. And I think those come up a little more in machine learning pipelines. So finally, I'm going to just basically recap what I'm here to talk about. Step number one, why does it keep happening? There's nothing special about machine learning deployments, but there are factors that exacerbate some of these problems, having to do with who is the core developers of the original intellectual idea of that model. If you find in your company that you're encountering this problem over and over again, you might say, what can we, knowing that there are factors that exacerbate this problem, what can we do to address these factors? Do we need to think about training our data scientists better? Do we need to think about bringing in engineering earlier? Do we need to think about restricting them into such a tight box of what they're allowed to deliver that in the end, the thing that they deliver, it's kind of impossible for it not to be easily deployable because we constrict them to code snippets that then can be easily deployed? If that's, you have to think about, you might want to proactively address that problem. How do I know a project needs an intervention? There are really classic smells that tell you something about this project is really getting stuck. However, I would say a code review with a machine learning scientist or engineer can give you a more accurate assessment. Where do you start? The goal is to get to an easy to maintain steady state. The scale of your intervention depends on how far off a project is from meeting its SLAs. But in the end, you got to put in the work. You got to actually reconstruct and re-architect a code that usually is going to be a kind of an expensive, experienced person. So honestly, the best thing to think about is, going back to the beginning, how can you keep yourself from getting in that situation of needing to do an expensive intervention in the first place? Thank you for listening to my talk, and I'd be happy to take questions.